Hi everyone, today we are proud to present Rgb Kirchhoff, a digital innovation designed to make learning Kirchhoff's laws more visual, interactive, and student-centered. This innovation is the result of a collaborative effort led by Suhaya Mukhtar, together with Nurun Ain Najwa Nordin, Tengku Ainun Marshida Tengku Hassan, Nur Atika Jafar, Nur Ain Fajrina Muhammad Sharuddin, Nurliana Bashir Gaus, and Muhammad Zulfadli Ramlan. Together, we are a team of educators from College Matrikulasi Melaka. Kirchhoff's laws can be challenging for students, especially when dealing with circuits involving multiple loops and more than one e.m.f. source. Students often struggle to determine the correct current directions and construct three simultaneous equations accurately. Therefore, there is a need for a learning approach that is more visual, interactive, and engaging, while allowing students to check and improve their own understanding. Rgb Kirchhoff was developed with several key objectives. First, it aims to improve students' visualization of complex circuits through an interactive GeoGebra simulation. Second, the RGB color coding system helps students identify different current paths and construct simultaneous equations more accurately. Finally, Rgb Kirchhoff aims to improve students' understanding, confidence, and interest in learning. Implementation of Rgb Kirchhoff follows the Deming model, which consists of 4 stages: plan, do, check, and act. First, in the plan stage, we identified the main difficulties faced by students when learning Kirchhoff's laws. Next, during the do stage, we developed the prototype, starting from manual sketches, followed by Microsoft Excel, and finally an interactive GeoGebra simulation. In the check stage, we evaluated its effectiveness through pre- and post-tests, as well as student feedback. Finally, in the act stage, we analyzed the findings and made further improvements to enhance the innovation. Here's our innovation: Rgb Kirchhoff, developed using GeoGebra. Through interactive visualization, students can clearly identify current paths and better understand Kirchhoff's laws. Feel free to scan the QR code to explore our demonstration. Rgb Kirchhoff represents a paradigm shift from the traditional approach to a more visual and interactive learning experience. Instead of relying solely on static circuit sketches and manually checking equations, students can now use dynamic simulations, RGB color coding, and built-in self-checking features. This approach allows students to actively explore the circuit, identify current paths, and understand the relationship between the circuit and its equations. As a result, learning becomes more interactive, engaging, and student-centered. Students use Rgb Kirchhoff to identify current paths, understand circuit relationships, and construct the required equations systematically. Implementation of Rgb Kirchhoff has shown a significant improvement in students' mastery of Kirchhoff's laws. Students are now better able to differentiate between currents I1, I2, and I3, determine their respective directions, and construct 3 simultaneous equations more systematically. More importantly, the visualization helps students understand the relationship between the circuit, current paths, and equations, rather than simply following calculation steps. This transforms students from being confused by complex circuits into more confident and independent problem solvers. Student feedback shows that Rgb Kirchhoff makes learning more engaging and enjoyable. The interactive simulation and RGB color coding help students visualize complex circuits and understand difficult concepts. In terms of user satisfaction, Rgb Kirchhoff achieved an impressive overall satisfaction rating of 97%. All key performance indicators also recorded scores above the 90% threshold, indicating a highly positive response from the users. These results show that students found Rgb Kirchhoff to be useful, engaging, and easy to use in supporting their learning of Kirchhoff's laws. Rgb Kirchhoff creates an impact in 4 key areas. First, it saves time by allowing students to perform calculations and verify their solutions more efficiently. Second, it is cost-effective, as it uses GeoGebra, which is free and does not require any additional hardware. Third, students can explore and solve more variations of circuit problems within a single tutorial session. Finally, it shifts students' focus from simply performing calculations to understanding and interpreting the analysis. Overall, Rgb Kirchhoff makes the learning process more efficient, accessible, and meaningful. The main novelty of Rgb Kirchhoff is its RGB current color coding, which uses red, green, and blue to clearly distinguish different current paths within a circuit. The innovation also features an interactive circuit with drag-and-drop components, allowing students to explore and manipulate the circuit more easily. In addition, Rgb Kirchhoff can be accessed across various devices, making it flexible and convenient for different learning environments. Most importantly, the built-in self-checking feature allows students to verify their own solutions and identify mistakes independently. Together, these features make Rgb Kirchhoff a unique, interactive, and student-centered learning tool for understanding. Rgb Kirchhoff has strong potential to be expanded to other institutions. It can also be further developed with more circuit configurations and interactive features to support a wider range of students. The recognition and awards received by Rgb Kirchhoff motivate us to continue improving and expanding this innovation. In conclusion, Rgb Kirchhoff is not merely a calculation application. It is a new lens through which students can see science. By combining classical theory with modern interactive design, we are shaping a generation of students who are no longer afraid of complexity, but are ready to solve it. Thank you for your time and attention. We hope you enjoyed learning about Rgb Kirchhoff and its potential to make learning Kirchhoff's laws more visual, interactive, and engaging. Thank you.